Now let us discuss about the work done in rotating a dipole in an electric field. Now we will start with what a dipole is. A dipole is an arrangement where a positive and negative charge is separated by a small distance. So let this be positive charge plus q, and let another charge which is minus q, separated by a small distance. Let the distance be 2l. Now when you place this dipole in an electric field, obviously let me say an electric field which is a uniform electric field directed towards the right, and let me place this dipole in the electric field at an angle to the electric field. So this is my plus q and this is my minus q, separated by a distance 2l, and let it make an angle theta with the direction of the electric field. Now what will this plus q will feel when it is placed in an electric field? Now obviously you see an electric field direction is from a positive charge towards outwards, because electric field actually means the line direction means the lines of force points. So what are lines of force? If a positive charge is free to move and if it is kept nearby another positive charge and you leave it, it will take a particular path, and if you go on drawing that path, it becomes the lines of force. So electric field intensity actually is from this positive charge towards outwards. So you have placed a dipole in an electric field, its direction out is towards right. So this plus q will feel a force because of this electric field, because the electric field lines indicates that a positive test charge will move through this way. So you have to assume that there is a positive source charge out here which gives out the electric lines of force, and at this particular point this is the electric field intensity E. So this plus q will feel a force towards the right, and how much is that force? As per the Coulomb's law, you have a relationship for electric field intensity which is equal to E is equal to F by Q, which is the force experienced by a positive test charge placed at that point. So you can write F is equal to Q times E, and that is the force experienced by this positive test charge of the dipole, that is QE, towards right. So it is a repulsive force. Now what about this negative charge? He will be feeling a same magnitude force towards left, and this is an attractive force which is equal to Q times E. So if I write this as the positive direction, let this be the negative direction, so that's why I put a negative sign here, so being an attractive force. So what will this dipole feel? Dipole will feel a turning force, equal and opposite forces acting at a distance, so it feels a torque. The turning force is what you mean by the torque. So how much is the torque experience? For that, you know, torque is equal to, denoted by the letter tau, is equal to any one of the force multiplied by perpendicular distance between the forces. So in this case, any one force, the torque is equal to any one force, that is Q times E, multiplied by the perpendicular distance. So normally when we say the perpendicular distance, child will take this particular length. No, that's not the perpendicular distance. Between the forces is what they mark. So this is the perpendicular distance between the forces. So this length is 2l, and how to find the perpendicular distance? So you can see the angle which is created is theta. So if you take the sine theta will be equal to opposite side by hypotenuse. Opposite side is my perpendicular distance divided by hypotenuse gives the 2l. So my perpendicular distance will be equal to 2L times sine theta. So for this finding torque, I will substitute this 2L times sine theta out there. So it will become 2L times sine theta. Now, how much is this Q times 2L? Q times 2L becomes, you have learned already that this Q times 2L is the dipole moment denoted by the letter P. It is also a vector. So you can write 2 times QL gives you the dipole moment. And if you substitute it there, it will become torque equals P E sine theta. Now P sine theta is similar to AB sine theta, and you can write it in the vector form. Actually A cross B is AB sine theta, so you can write P sine theta as P cross A. So you have the torque, which is also a vector, equal to P vector multiplied by E vector. So this is the formula to find the torque experienced by the dipole. Now the question is, how much work is done to turn the dipole in the electric field. Now let me see it. The dipole is in an electric field pointing from left to right, and let the dipole is as aligned in the direction of the electric field. That is plus Q in this direction and minus Q here. The distance is 2L. Now, how much work I have to do to turn this dipole? So to find the work done to turn the dipole, work done is equal to force times displacement. In this particular case, my intention is to turn the dipole. So what is the turning force? That is the torque experience. Torque times what is the displacement I want to achieve? It is the angular displacement. The torque times the angular displacement. So work done is, let my intention to turn is, this dipole is from an angle of 0 degrees, that is when it is aligned in the direction of the electric field, the angle is 0, to an angle theta. So what should I do? I have to find the work done for each small angle d theta and then to integrate. So let me start by writing the work done to turn the dipole by a small angle d theta. How much is the work done? The turning force, that is a torque, that is P E sine theta, multiplied by how much I have to turn, a small angle d theta. Now my intention is to find out the work done to turn it from an angle 0 to an angle theta of my choice. So what should I do? The total work done to turn it from an angle 0 to an angle theta is equal to integral this P E sine theta d theta. Now P and E be a constant, you can take it out and you can write it like total work done is equal to PE integral 0 to theta sine theta d theta. Now how much is integral sine theta? Integral sine theta d theta is equal to minus cos theta. Just reverse of the differentiation, but the sign change. So you can have total work done equal to PE minus cos theta. Then I have to put the lower limit and the upper limit. So first I have to put the lower limit value, that is minus cos theta minus again minus cos 0, that is the lower limit. This cos 0 is equal to 1. So you have PE minus cos theta minus 1. So this will become plus, and you will have PE times 1 minus cos theta, which is the total work done to turn the dipole by an angle theta in an electric field of E. Hope you understood the logic. Thank you.